minutes. So, and it won't hurt that much. So we're going to learn about where pi comes from, and I'm going to do it with a little sketch pad activity. So I'm going to draw a circle, okay, which you can do, and then I'm going to draw a diameter to my circle. And the way I figured out how to best construct a diameter is by putting a point on the line and make sure it goes through the center of the circle. Let's move on. Where does pi come from? A lot of you guys know what pi is about, or you know of pi, and some of you already know. But yeah, but where does it come from? So I'm going to put a point there. I'm going to put a point there. I'm going to make a segment on top of there. Okay. I tried this last night to make sure it worked.
That's good.
And I'm going to click on this, and I'm going to display pi to line. And now I should have a circle with its diameter because I constructed that so that it goes through the center of the circle. And then if I drag this circle around, it should stay at diameter, right? Like I did it, and I could twist it and turn it and things like that. And that thing is always a diameter. I could spin it around. I could get dizzy. Ooh, that's cool. Okay. So anyway, so the first thing I'm going to do is I'm going to click on that, and I'm going to go to measure. Click on this, measure, and I'm going to go to. Doesn't work. I have too many things selected. Measure circumference, okay? So there is the circumference of that circle. And now what I'm going to do is I'm going to go this to here, okay? And I'm going to go measure distance. And that is 8.49.
And then top.
Let me finish, okay? And then I'm going to go number, calculate. And I'm going to go this divided by this, okay? And I hit OK. And what I get is this number, which is 3.14. And you might say, well, that's not exactly pi. And that's because that's not, these numbers are rounded off, right? So if I went to more decimal places, which I'm going to show you in a minute, I get more digits of pi. So, and notice that if I change the size of this circle, that circumference changes and that diameter changes, but the ratio of the circumference to the diameter stays the same. So let me just show you something because I think it's kind of cool. If I go to edit preferences and I change this to like 10 thousandths, and I change this to 10 thousandths, and now if I hit OK, and now if I want to measure now, watch, measure circumference, I'm going to put that over here, and then I'm going to go boom, boom, measure, yeah, we're getting there, okay, distance, okay? And then if I go number, calculate, this divided by this, and okay. You guys, some of you know a bunch of digits of pi, right? But now I'm going to 3.14159, blah, 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 blah. Okay? 3.14159, right? And then it goes around. So this is rounded up. So, and that ratio doesn't change either as I change the size of the circumference. So that's part of the reason that pi. That's part of the reason that pi is an irrational number, because it is only as accurate as the tools you have for measuring the ratio of the circumference to the diameter, right? So if you have a super accurate instrument, you can measure pi. But no one has ever proven that pi is a rational number, meaning it's one that either starts repeating itself or terminates, or it can be expressed.
How does it just keep going on forever? That just doesn't make sense.
That does make sense. Neither does that make sense with the universe.
Who made?
Who knows? All right.
Yeah,
So
who
anyway,
figured that out?
Who invented that?
Yeah.
who invented that?
Who
The
invented
Greeks. Okay. They meant because it's very useful.
That was so frustrating in those days.
How do you like notice that? Like, they're dumb. Like, really? Like,
Inventor?
truthfully, they're stupid. Like, if they can't figure the end of that number out.
How'd they figure that out if they didn't have calculus?
Maybe the Greeks didn't know that it went on forever, but and they used approximations for pi. One approximation that they use for pi is whoops.
That is so
Okay. Where did that come from? Okay. Where did I go? Oh, I don't mind. One approximation that they use for pi is 22 sevenths. Okay, so that they said, come on, that they said that this is about equal to. It's about equal to 22 over 7. So if you take 22 over 7, it comes out, it's pretty close to pi. So pi, if you ever want to express this fraction, sometimes they'll say use that as an approximation. Okay? So pi is, so you should write this down. Pi is the ratio of C over D in a circle, or more commonly, circumference is equal to pi times d, or in a more familiar form, which you may have seen, circumference is equal to 2 pi times r. So all of these formulas are kind of the same thing, right? Here they just split the diameter into 2 and r, and usually you put the number piece in front of the letter and symbol piece. So circumference is pi d. Pi is circumference divided by diameter, and circumference is 2 pi r. But that becomes very useful when you're trying to calculate distances around things, okay? Or how far it is across your circumferences, and it comes up a lot in all kinds of applications. And then as you get into 3 dimensions, it has all kinds of applications, and so on and so forth.
What's pi r squared? What does that equal?
Area of the circle. We haven't done that yet.
Oh, that's well, you learned that.
Okay. Yeah, you'll learn it again. Okay. So, so then we have some example problems. So they'll say like, yeah, this is easy. You'll have a circle, and your circle, where's my circle? Here's a circle, and they'll say something like, the circumference equals 10 pi inches. What's the diameter? Okay. What's D?
10.
Okay. And so I would use the formula C equals pi times D. And then I would plug in 10 pi over here. And a lot of people get confused. They want to multiply that together right away. But what happens to the pi's?
Oh, wait.
You could cancel out the pi's, and you get that D is equal to 10 inches.
Wait,
okay?
so does that work for all of them then?
It depends. So,
Wait, if it says if C.
in terms of pi, okay? Now, in other cases, they might. Am I recording? Am I recording? I'm recording. So, in other cases, they might say something like the radius of a circle, radius equals 6 feet. Find the circumference. Find, that should be a find. Okay? Find, I erased. Find the circumference.
So it'll be 12 times 3.14.
So just plug in, depending on which things are given, now you can use 2 pi r, right? And you plug in 6 in there. So you get circumference is equal to 2 times pi times 6, which is, in exact terms, 12 pi feet, right? And they might say use 3.14 as an approximation of pi, or you can use that on your calculator. So if I have a graphing calculator, which I happen to have, I am right. Okay, I can just go to find that answer. Whoops. I can just go 12. So if they ask you for the nearest, if they say in exact terms, you would ask 12 pi. If they say to the nearest tenth, then you go to your calculator and you go 12 times. You don't even have to do times. I have my pi is up here, I believe. Is that my pi? No, that's an e. I can't see that this pi over here. Second pi. I think this might be pi. No, I can't see. Second. Oh, it's right there. Second pi on my calculator. And then if I hit enter, I get that is approximately, if they said to the nearest tenth, that would be 37.7. Okay? 37.7. Always put units on these things. Okay? Going the other way, to find circumferences to the near, we just found a circumference to the nearest tenth. So say they did something like this, the circumference, so, yes?
Do you multiply the 2 times the 6 first and then times pi, or do you do 2 times pi times 6?
Doesn't matter, okay?
Oh, you give this.
Yeah,
Okay.
multiplication is commutative,
okay, right.
yeah, so it doesn't matter, and associative, it doesn't matter which order you do it in, okay? So then, next thing, say they did one like circumference of a circle is 50 meters. 50 meters to the nearest tenth, to the nearest tenth of a meter. Find the radius. Okay. So then what you want to do is again, I would just write down your equation so that you have something to solve for. And you know that this is 50 and this is 2 pi. R is what you're solving for. So R is going to be equal to 50 divided by 2 pi. That's your exact answer. And to get an actual answer, be careful when you're using your calculator, okay? Because what you don't want to do, you don't want to do this, 50 divided by 2 pi. You don't want to do that, because even though it looks right, I don't think that's going to, because I think what this is going to do is going to take 50 divided by 2 and then multiply it by pi. Let's just see. Because I should get an answer 50 divided by 6. I don't know what that is. So see how it gives you 78? And that answer doesn't make sense, right? And so what you want to do, you want to, whoops, where's that entry button? Second entry. There we go. What you want to do is you want to put parentheses about that, okay? So you want to go 50 divided by, and I think most calculators ask you to do this, 2 second pi is over here. And then if I do that, I get that seems to make more sense, right? And so that comes out to be, to the nearest tenth, that would be, how can that? 7.96. Now, well, to the nearest tenth would be 7 point, actually to the nearest tenth, it would be 8.0, right? Because you round up this to 10, right? So this would be 8. Okay, and that would be in meters.
Just 2 meters.
Yes, sir.
If you divide it by 2, then divide it by pi first.
Yeah, that would work too. Yeah, you could go divide by 2, divided by pi. So your homework, do you have your homework? It's on your assignment sheet. It is, What?
333, not 334.
It's page, sorry. It's page 333. 333. 1 through 11, because they said 1 through 10 and 11. So 1 through 11, 13, 15, 16, 18, 19, and 20. I want you to show work, okay? Don't just give me an answer. Show work. So that means, like I was doing, setting up the equations and stuff like that. Okay? The end. And remember, you heard it here on the Monarch Coyote Station.
Ooh, Mommy, you can change it.
Okay? Yeah, I'm changing it.